Hello, everybody. Thank you very much. Okay, let's start. My name is Mamaladze. I am senior software architect in Siemens in Germany. I work in Germany. And today my topic is human-machine interface, past, present, and the future. What's the presentation about? So yesterday you got the stickers, I hope, each of you, and the let's touch the future. So the conference is about design, business, tech, and the future. And we will touch very probably each of these topics. So we will touch design, we will touch tech, we will touch future, and maybe a little bit business. But before we start, I have a question to you. How many of you have to deal with this software, like websites, apps, any kind of software in your business or at work? Please raise your hands. Okay, so that's the software, that's what I call soft tech. Now, please raise your hands if you have to deal with machines in your daily business, like production machines, drones, robots, stuff like that. One hand, two, three. Okay, not too many hands, but this is what I call hard tech. And not many people in Georgia have to do with hard tech. It's much more in Germany, for instance. Germany is the nation of machines. And that's what my talk would be about, and mostly about the interaction of humans with machines. At the beginning, I want to get rid of a personal note. So I'm very excited and very happy to speak here in Tbilisi, in the city where I was born and spent the first half of my life, to the Georgian audience. But I'm extremely proud today, and an exceptional opportunity, thank you for the exceptional opportunity, Touch, to stay here. And why? So this is me. Exactly 40 years ago, it was a elementary school Christmas concert, and I had a key role, which I totally messed up. And my teacher, Mamaladze, was very upset at me, and she told me that my future at the theater is impossible, so I have no future at the theater. And today I'm standing here in the Rustaveli Theater on the stage. So, bam, Mamaladze. Please don't ask me what this man in a paramilitary uniform is doing there at the Christmas concert at the elementary school. It was 90s, so that was a normal thing. Good, so we start with the past. So we will do a historical journey about human-machine interaction, and I will take you in the historical journey, and we will touch all this stuff. And first thing I want to talk about is a telegraph, invention of a telegraph. Until the invention of the telegraph, human-to-human communication took place through the verbal messages or written messages, and the interaction remained in the real world. And with an invention of telegraph, happened a big revolution, which remains until today. So today we are exchanging messages using apps, using internet, using different means, telephones, whatever. But the principle is the same, that our message leaves the real space, goes into the virtual space, and then it is consumed by the receiver from the virtual space. So it means that every time a message leaves the real space and goes into the virtual space, it needs to be translated into the machine language, and here it needs to be translated back from the machine language into the human language. And this translation and these places are exactly human-machine places where human-machine interaction takes place, and telegraph was the first thing enabling that human-machine interaction. So it was invention by Siemens at 1847, which triggered this revolution. It's about 180 years ago, if you think about that. So 180 years ago, this brilliant device and technique was invented. And interestingly enough, the it triggered a huge revolution. And the center of this revolution, one of the centers of the revolution, was Tbilisi. Interestingly enough, this is Lado Asatiani Street, and there is a memorial table on the Lado Asatiani Street where the Siemens brothers visited and lived for a while. And it's not a random decision for them to come to Tbilisi and do their business here. They built the first transcontinental telegraph line connecting London to Calcutta to transfer telegraph messages. And Tbilisi was right in the middle, and they decided to. And it was very convenient and easy to manage whole thing from there. So the Tbilisi was a tech hub at that point, at this revolution. And now I want you to see the demonstration of this device. It's a brilliant thing because at that time the cables were not capable of transferring gigabytes of data or voice or whatever. So one thing the cable was able to transfer on these distances was just a clicking. Tick, 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 just this thing. And using just clicking, they invented a device which was able to transfer the message from human to machine and from machine to human back using just this clicking. Please take a look at the demonstration how this device works. There is no sound. I expected to have a sound here. So you would hear clicking in the background, like click, 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 and whenever it comes to the letter, it stops there. Okay. Okay, let me click through it. So this is the sending device, and this is the receiving device. Whenever you click N on the sending device, the clicking stops at the letter I, for instance, and yeah, you see? Now it arrives to N, stops there, and it stops also here. This is the receiving side. So this device is a grandfather of our keyboard. So this invention triggered the revolution. The next step in the revolution was basically invention of a screen. It's another component of human-machine interaction, especially touchscreen is what we use today. In 1975, Siemens filed a patent for a touchscreen. So, but it was a resistive touchscreen. The touchscreens which we use are not resistive, they are capacitive touchscreens. But doesn't matter, the principle is the same. And this invention of a screen triggered another step in this revolution. And now I want to tell you a short story about the machines in our life. So you may think there are not too many machines in our life, yeah, because they are hidden. They do job in the background. So, and we are not aware about them. All the time we consume products which are produced by the machines. But we are ignorant about that, like my daughter. Once we sent our daughter to grandparents in the village, and I was back in Germany, and she called me one day saying, Papa, you know, here apples are growing on the trees. Because her perception was the apples are just laying around in the supermarket, and she had not realized until then that the apples are actually growing on the trees. So we laugh about that, but we ourselves are very ignorant about that. For instance, I live in Munich. I love this city very much, and our tradition is, of course, once a year, Oktoberfest, where we drink a lot of beer. Not only we, but the whole world visits us and drinks beer with us, and we consume like 7 million liters of beer during the Oktoberfest. It's a huge amount of the beer. And each of these guys, they think that the beer just arrives on their table, magically appears on their table without knowing where it comes from. So 7 million liters, it's a huge amount of beer, and you cannot store this beer in bottles somewhere there in the tent. And where the beer comes to Oktoberfest, because the Oktoberfest is a very limited space, and you cannot keep there 7 million liters of beer cooled down to the temperature where it can be consumed. So, and the secret is, it's pumped through the pipeline. There is a huge pipeline underground which pumps beer from special storage places to the beer tents where it is consumed. And this system is created by Siemens, and it's fully automated. And it's a machine in background doing this thing for you. And you think that the beer just arrives at your table, and there is a huge machinery behind it. Siemens is also producing a brewery equipment. A brewery is a high-tech business. You may think like there is a worker which brews the beer just as simple as it looks like, but there is a huge factory which is controlled by a machine producing beer. And what you see here in front of the factory, these are computers, these are screens which control this machine. So only 4 people is enough to operate this huge beer factory. And we achieve that through the optimized human-machine interaction. So now back to this diagram. So in the previous diagram, we had a human on the left side and human on the right side, and there was a message coming from the human to other human. Here we have a human interacting with a machine, and you see that the message gets broader here. The point is that the challenge with this type of human-machine interface is that the perception capacity of a human is very limited. And in the machine, there are a lot of things happening, a lot of data coming, a lot of measurements, and so on. And if the whole factory would send all the messages, all the data it produced to a human, the human will be easily overwhelmed. So what we need is we need to condense the huge amount of the data which is coming from the machine and deliver it to the human so that human can react and issue high-level commands like magic button. Just click a magic button, which will on its side convert into the hundreds and thousands of the commands and ones and zeros and sent to the machine. So here the human-machine interface designing this human-machine interface is a very challenging job. It requires a special software and special hardware, and that's what I personally work on. And this human-machine interface may look very standard, like a PC station with a special software. The software looks like this. Or it could be a special control panel which controls a robot. So you see a robot in the background and the control panel with a special hardware and special software which controls the robot. Or it could be a specialized working station with these dials and all these buttons, which is adjusted to the machine, which is controlled by this human-machine interface. This one, yeah. Things like that. You can also you can see things like that in a medicine or wherever. So this is also one type of human-machine interface. Now let's touch the future. Okay, what is the future of the a control panel like this? And this is the most exciting part of my talk, I guess, I hope. Yeah. And we do recap again. We have the human-to-human communication where the message goes from the real world into the virtual, from virtual into the real. But there is also, this is the human-machine interaction, but there is one more type of the human-machine interaction, which is very probably the oldest one, but it gets unnoticed because, for instance, computer games. This is the human interacting with a simulation running inside the machine. It's, for instance, an example of it is a computer game. Yeah, so human is interacting with a virtual world which stays virtual. So it's remains in the virtual world completely, and the human interacts with this virtual model, which is computer game in this case. But this is the very first computer from Manhattan Project. Have you heard about Manhattan Project? So there was a governmental project in US where they basically tried to invent a nuclear bomb, right? And nuclear weapons. And they only goal of this computer was a computer simulation. So what they did is basically they wanted to find a critical mass of a nuclear explosion needed for the nuclear explosion. So there is a certain mass of uranium you need to trigger this chain reaction for the nuclear explosion. And there were different ways of finding that. So you could gather the uranium, make an explosion, see if it works, or add or remove uranium then, yeah? And it would be very dangerous and very costly. So what they did, they created a computer model of a nuclear explosion, and they simulated different amounts of uranium, different configurations of this bomb, and found the one which worked. So that was the Manhattan Project, and the very first use of your computer was basically a computer simulation. And now I want to talk about the industrial metaverse. It's a virtual world to solve real world problems. So industrial metaverse is a real thing, and it exists, and it's sold by Siemens, but it's a very new one, and it did not arrive at the market broadly. So it takes always 5, 10, even 15 years until things arrive at the market broadly. And it's a pretty new thing. And these two guys, this one is Roland Busch, CEO of Siemens, and this is Jensen Huang, who is the CEO of NVIDIA. So Siemens and NVIDIA partnered to create an industrial metaverse. Industrial metaverse is basically a simulation, which is a very realistic simulation of machines, including every detail of a hardware and software in the cloud. So let me show you the demonstration how it looks like. So this is a factory. It looks very realistic, but it's simulated. And on the left side, you see Siemens software, which is able to do a physically correct simulations of a hardware and the software. And on the right side, you see the same thing rendered by NVIDIA in a photorealistic detail, including ray tracing and everything. So it's a very useful thing to create a simulation of a factory before you build it, to try it out, to try it with different configurations. So that's how I hope engineers will work in the future. So they will create machines, they will create software and test and arrange the software in a factory virtually at the very beginning, and then they will transfer it into the reality. Another use case of this industrial metaverse is that you could create a simulation, a copy of a factory in a virtual world, and connect it to the real machine, so that the real machine and virtual machine, they reflect the states of each other and work together. This opens up additional use cases, like, for instance, diagnosing the bug. So also machines have bugs, and the software in the machines may have bugs or problems. And you identify the problem, you fix the problem inside the virtual machine without stopping the real factory for that, because every minute, every day you stop the factory costs you money. So without stopping the factory, you can test your change in the virtual world, see how it works out, and if it's good, if it fixes your problem, you can roll it out, or you can test different variants and see which variant works better. So that's and this principle is called digital twin. So what you do basically is you create a twin copy of your machine inside your virtual world, and human is interacting with the virtual copy of the machine instead of interacting with the real machine. And the virtual machine, basically running as a digital twin in this industrial metaverse, does all the calculations and simulations for you. Okay, so that's the industrial metaverse, which is future, but kind of very close future. What is the next step? Maybe there is a next step, and the next step is as we copied created a twin of a machine inside the virtual world, we can also clone the human and put a virtual human into the virtual world side by side with the virtual machine. And we're already experimenting with that, and this is the picture of a real experiment where a human worker goes into the virtual factory, which is on its side connected to a real factory. So basically we have a digital twin of a human and a digital twin of a factory interacting with each other in the virtual factory, and there is a real human on one side and a real factory on the other side. So the possibilities are open. I don't know. There are hundreds of use cases which are possible thanks to that technology, and this is an open platform where the people can also, the people and companies, they can also contribute, write their software, and interact with this virtual world. Let's see what comes out. So this is, my intention with this talk was to demonstrate this historical journey and show you the brilliant design, the old brilliant design, which then transformed and where it went. So I hope I was able to inspire you with the hard tech and this virtual world of the machines, and I will be very happy if you find opportunities in there, because the software is not just a website or an app on Android or iPhone. So this is also software and a very meaningful part of our life, which is mostly hidden for us and works for us in the background. Okay, thank you very much.